couple things I like to do before I begin adding or subtracting fractions is if it's a subtraction problem, I always like to begin with changing it to an addition sign and then changing all the signs in the numerator afterwards. So rather than subtracting, I'm going to make this plus a -2. That's going to be really important because I may end up distributing, and I want to make sure I remember to distribute a -2, not just a 2. And so that's one thing I like to do right away if I see subtraction. The other thing is if I cannot factor the denominators, like in this case I can't, I want to group those up or chunk them together, I say. So I know that those are not going to be able to be separated. X minus 3 is one single entity. I can't break that apart. The subtracting sign kind of glues that denominator together. And so since, as I just said, nothing can be factored, I can go ahead and start to build my least common denominator. I can't add or subtract until I have the same denominators. In this case, there's no coefficients, as we've been talking about, other than just the ones in front. I don't really need that. So all I need are the variable pieces. So I have to take every variable piece that I see, and the highest power of them. There's just 2 pieces. So I'm going to need an x minus 3, and I'm going to need an x minus 1. That's sort of the ideal bicycle, if you've watched the other videos that I've been talking about. The ideal bicycle or the ideal denominator. I want to turn both of my denominators into that denominator. And so what I'll do, I want to compare. This first fraction has x minus 3, so you can kind of even do this as a checklist. I have that piece, I have sort of the wheels of the bike, but I don't have that x minus 1 piece, and so what I'll need to do is multiply not just the denominator, but also the numerator by x minus 1, by whatever piece is missing. Notice I included that in parentheses, because when I multiply that by the x that's already up there, I'll need to remember to distribute, okay? And in the last video we talked about why it's important to multiply the top and bottom by the same thing, because really that's just a 1, and multiplying something by 1 does not change anything, okay? Let's move on to the second fraction. This one has x minus 1, so again, if you would like to do the checklist thing, I have that piece, I have that part of the bike, but I don't have x minus 3, and so I'll need to multiply not just the denominator, but the numerator as well by x minus 3. And if you take a look, I'm going to have to end up distributing that -2. That's why I wanted to make sure it was a negative that I remembered to distribute. Okay? So actually I can go ahead and find, or start to get my final answer put together. I'm going to make one big fraction line. I like to skip a step. If you watched me do this in class, I showed you an extra step in between here. But I like to skip it usually. That denominator is going to be the least common denominator. It's going to stay the same, x minus 1 times x minus 3. And you do not need to multiply those together. In the numerator, then let me switch back to orange, I want to go ahead and multiply those parts together. So I do want to multiply in the numerator. So I'm going to end up with x squared minus x for that part. And then again, I've gone ahead and skipped a step and just made one big giant fraction because I know that would happen eventually anyway. Let me go ahead and distribute a -2. So I'll have minus 2x and then plus 6. So there's my answer all added together now as one giant fraction. The only thing left to do is do some simplifying, so let's go ahead and do that. So I'm going to combine like terms in the numerator. I've got x squared, I'll put this in descending order, minus 3x, and then plus 6. And what's sad is I see a lot of people get this answer and they stop there, and they forget that you still need that denominator, so don't forget that. And again, you do not need to multiply the denominators out. In fact, I prefer you don't. Just leave it x minus 1 times x minus 3. Now, one thing we should try to do is you should try to now refactor that numerator, because every now and then you can refactor the numerator and it ends up canceling something in the denominator. In this case, the numerator cannot be factored, but you should always try to, because every now and then it's able to be factored, and if you can factor and cancel, you have to factor and cancel. So it's worth checking for, although in this case it did not factor.